Hi guys, today we're going to look at standard form. Now hopefully this is a bit of revision for you. You are likely to have seen standard form in year 8, but if not, you will definitely have seen it at the beginning of year 9, as it is a topic that is taught at the beginning of year 9 on the scheme of work. So generally the format for standard form is a times 10 to the power of b, where a is a number between 1 and 10. So you can have the number 1 all the way up to 9.9 recurring. That's then multiplied by 10 to a power. Now that power can be any value, it can be positive and it can be negative. So a few examples just to get us started, to refresh our memory here, is if I've got 5.2 times 10 to the power of 6, I could have 3 times 10 to the power of minus 4. What I can't have though is something like 19.7 times 10 to the power of 5, because that 19.7 is not a number between 1 and 10. So if I have got 400, I want to write this in standard form. Now my decimal point at the moment is here, and therefore I'm going to have to jump twice to put my decimal point behind the 4, because remember it has to be between 1 and 9. So I have jumped twice here, so this is going to be 4 times 10 to the power of 2. If I have got 3,700, my decimal point is currently here, and I need to jump 3 times this time to make it 3.7. I've jumped 3 times, so it's to the power of 3. 28,500. I'm going to want to make my decimal point here to make it 2.85. The decimal point in the number is actually here, so I'm going to jump 1, 2, 3, 4 times, so it's 2.85 times 10 to the power of 4. If I have got 0.00275, I'm going to need to make my decimal point here. Now what you will notice is I'm actually going to be jumping the other way to what I did with my previous examples. So this point still stands the same, and this is going to be 2.75. However, because I have jumped in the opposite direction this time, my power is going to be negative. It's going to be negative 1, 2, 3, because I've done those 3 jumps. Again, 0.0143. This is where I would like my decimal point to end up. So it's going to be 1.43, and I have jumped twice, so it's times 10 to the power of negative 2. One more example, 0.000047635. I'm going to want the decimal point to be here, so 4.7635, and I have done 1, 2, 3, 4, 5 jumps, so it's going to be times 10 to the power of negative 5. So that's how we put ordinary numbers into standard form. How about if we have numbers that are in standard form and we are asked to put them into ordinary numbers? So 5 times 10 to the power of 8. So that means I'm going to have 5 with 8 zeros, because if the decimal point in the standard form is here, how many times have I jumped from my decimal point here to get here? 1, 2, 3, 4, 5, 6, 7, 8. Now generally you may have been taught before the power is the number of zeros. Now that works if the number is a whole number. How about if I have got something like 7.3 times 10 to the power of 4? Now what you notice is this 3 is holding a decimal place, and therefore it's going to eat into one of the zeros that I would put at the end. Instead, what I'm going to have is 3 zeros, because I would like to have 4, but that 3 is going to take up the space of one of them. So actually I'm only going to have 3 zeros. The theory still stands. If my decimal point is here and I jump 4 spaces, my decimal point still does end up where it is in the standard form. Another example for you, let's go 9.23 times 10 to the power of 5 this time. So I would want 5 zeros because of this power here. However, these two decimal places are going to eat up 2 of those zeros. So it's going to be 923 with 3 zeros because it eats up 2 of the 5 zeros I would want. 923 with 3 zeros. Let's check it. My decimal point is here. 1, 2, 3, 4, 5. That is where my decimal point is in my standard form. How about with negatives? So 2 times 10 to the power of negative 3. So this time the negative 3, if we go back to the examples that I just did earlier, all those negative ones were 0 point something. And you'll notice here, this negative 3, I've got 1, 2, 3 zeros in total, including the one before the decimal point. So for this one, including the one before the decimal point, I'm going to have 0.002. Another example, 8.54 times 10 to the power of negative 5. I'm going to have 5 zeros, including the one before the decimal point. So 0.0000854. Final one for you, 3.265 times 10 to the power of minus 1. Including the 0 before the decimal point, I only need 1 0, and therefore my answer is 0.3265. So that's how we write numbers that are in standard form as ordinary numbers and ordinary numbers as standard form. However, if I was given something like this, 57.5 times 10 to the power of 4. I hope that you are happy that this is not in standard form, and it's not in standard form because this is 57.5. That's not a number between 1 and 10. So what I'm going to do is the number I would like to make it is 5.75. To get 5.75 from 57.5, I have actually divided this by 10. Hopefully we're happy with that. And because I've divided that by 10, I then need to multiply this by 10. And the reason I need to multiply this by 10 is because I need to keep it exactly the same. So if I've divided by 10 here, to keep the number exactly the same value, I'm going to need to multiply by 10 here. If I've got 10 to the power of 4, and I multiply it by 10, using my laws of indices, technically that's a power of 1 that 10's got. So when I'm multiplying, I add my powers, so it becomes times 10 to the power of 5. This is now that written in standard form. Another example for you, 0.36 times 10 to the power of 8. I need to multiply this number by 10 to make it 3.6, because 0.36 is a number less than 1 and it's got to be 1 or greater, up to 9.9 recurring. Because I've multiplied this by 10, I'm going to have to divide this by 10. When I divide by 10, I'm going to subtract a power here. So it's going to become 10 to the power of 7. Another example, 185.2 times 10 to the power of 7. Now this time what I'm going to have to do is I want to make it 1.852. Now to get from here to here, I have divided by 100. So this time I'm going to need to multiply by 100. Now 100, remember, is 10 times 10, which is 10 squared. So I'm going to have to add 2 to my power here. So I get times 10 to the power of 9. Let's see that with some negative powers then. So 24.3 times 10 to the power of negative 5. I'm going to need to divide this by 10 to make it 2.43. Because I've divided this by 10, I'm going to need to multiply this by 10. And remember, when you multiply by 10, it means you add a power on. So negative 5 add 1 is going to get me negative 4. Another example for you, 0.193 multiplied by 10 to the power of negative 9. I would like to make the number 1.93, so I have multiplied that by 10 this time, and therefore I'm going to have to divide by 10. So remember, when I divide, I'm going to have to subtract 1 from my power, so this is going to become 10 to the power of negative 10. One final example on this, 325 times 10 to the power of negative 8. So to make this a number between 1 and 10, I would like to make it 3.25. So I have divided it by 100, which remember is 10 squared. And because I've divided this number by 100, I'm going to have to multiply by 100 here. Remember, that's 10 squared, which is what I was about to say here, but it makes a little bit more sense to write it here. That's 10 squared, and because I've multiplied by 10 squared, I'm going to have to add on that power of 2. So this is going to become times 10 to the power of negative 6. Okay, so those are the sort of basic questions for standard form. And now what I'm going to look at is some calculations with standard form. Now, you can do this on a calculator or on a non-calculator paper. You will be expected to obviously do it without a calculator. So what I'm going to do is I'm going to show you all of the examples without a calculator. And then what I'm going to do is I'm just going to show you one example as to how to type it into your calculator, which you could then transfer across future questions if you get it on a calculator paper. So, my first question is 3 times 10 to the power of 4 plus 7 times 10 to the power of 3. Now, unfortunately, there's no easy way other than converting these into ordinary numbers and then adding them. So this is 30,000, and this is 7,000. I then add these together, I get 37,000. As simple as that. The question may ask for you to convert it into standard form at the end, then obviously you can do that using your rule. It would be 3.7 times 10 to the power of 4. Question 2, 1.4 times 10 to the power of 5 minus 2.6 times 10 to the power of 4. Again, we are subtracting this time. It doesn't matter about the brackets. Sometimes questions will do it without brackets, sometimes questions will do it with brackets. And that's why I've done those two different examples. When subtracting, it follows a very similar format to the addition. I have to convert them into ordinary numbers to be able to do the sum. Remember, this decimal point is going to eat up one of my zeros. So I end up with 140,000 minus, again this 6 is going to eat up one of my zeros, 26,000. So I would just work this out. Not talking this through because hopefully you're happy with that, and therefore I get the answer of 114,000. Again, the question asks you to put it into standard form. You can do that with what we did at the beginning of the video. Example 3, I'm going to move on to multiplication now. So I've got 5 times 10 to the power of 4 multiplied by 3 times 10 to the power of 11. To do this question, what I would do, and there are many different ways that you can do it, I'm just showing you my preferred method. So what I would do is 5 times 3, which is obviously 15, and I would do 10 to the power of 4 multiplied by 10 to the power of 11. That, remember, when I've got powers and I'm multiplying, I add them together, so I get 10 to the power of 15. Now because it's standard form, obviously it's going to be the number times 10 to the power of whatever it is. Now this is not into standard form, so I have to use the skill that I just taught you in the previous examples. I'm going to want to make this 1.5, so I have divided by 10. Because I've divided by 10 there, I'm going to have to times by 10 here, so it's going to be 1.5 times 10 to the power of 16. Example 4 is 4.6 times 10 to the power of 3 multiplied by 1.7 times 10 to the power of minus 5. Again, just an example that's got brackets in. It's exactly the same, it works exactly the same way. So I'm going to do 4.6 multiplied by 1.7, and I'm going to do 10 to the power of 3 multiplied by 10 to the power of minus 5. So to do this decimal calculation of 4.6 times 1.7, what I'm going to do is I'm going to just multiply each of these by 10, which means I'm going to have 46 times by 17, and then what I need to do is to remember to divide by 100 at the end, because I've multiplied this by 10 and multiplied this by 10, so actually overall I have multiplied by 100. So I need to remember to divide by the 100 at the end. 46 multiplied by 17, 6 7s are 42, and I get that value, and I need to remember to divide that by 2, so the 4.6 multiplied by 1.7 is 7.82, because I've divided this by 100. And then 10 to the power of 3 multiplied by 10 to the power of minus 5, I need to make sure that I add my powers. 3 add negative 5 is going to get me 10 to the power of negative 2. And remembering that I need the times in there to keep it in standard form. I just need to check that this is in standard form. It is, so that's great. I can move on to my next question. Number 5 is 2.5 times 10 to the power of 9 divided by 5 times 10 to the power of negative 4. And this one works in exactly the same way as the multiplication. I do 2.5 divided by 5 and 10 to the power of 9 divided by 10 to the power of minus 4. So, I didn't write the 5 in. 2.5 divided by 5. Now, if you can't do this in your head, you can absolutely do a bus stop, dividing by 5, and we are dividing 2.5. So, 5 into 2 doesn't go, carry the 2, 5 into 25 goes 5. So I've got 0.5 here. 10 to the power of 9 divided by 10 to the power of minus 4. I'm dividing, so I need to subtract my powers. So 9 take away a -4 means I'm actually going to add them. So I get 10 to the power of 13. Remember, it's standard form, so we need to keep that format, 0.5 times 10 to the power of 13. This isn't in standard form again, and therefore what I'm going to do is I want to multiply the 0.5 by 10 to get me 5. Because I've multiplied by 10 here, I need to divide by 10 here, so that means I'm going to have to subtract a power, so I get 5 times 10 to the power of 12. One final example for you, and then I'll quickly show you how to type it into your calculator. My final example is 3.672 times 10 to the power of -3 divided by 1.2 times 10 to the power of 4. Now, when I'm doing this question, I'm heavily relying that you are confident in working with decimals, multiplying and dividing decimals as well. So if you're not, you might need to go away and do a little bit of practice on that, just to really build your confidence on these questions. So first thing I'm going to do is 3.672 divided by 1.2. Now, I think that's a really nasty question to have to work out. I'm a lot happier if I am able to divide by 12. So what I'm going to do, if I multiply the 1.2 by 10, I have to multiply the number that is being divided by that number by 10 also. So I've got 36.72. Now, because of the rules of division, I don't actually have to then divide by 100 like I did with the multiplication at the end. It's only with the multiplication that I have to do that. I'm now going to divide this. 36.72 divided by 12 goes in 3 times, doesn't go, and carry the 7, 6. So I get 3.06 for that part of the working. And then I am going to do 10 to the power of -3 divided by 10 10 to the power of 4. Remember to subtract your powers when dividing, so that's going to get me 10 to the power of -7, because it's -3 take away 4. And remembering, in our standard form, 3.06 times 10 to the power of -7. This is in standard form. That's great. I don't have anything to do with that there. So what I'm going to do is I'm just going to show you how to do this question using a calculator. So I'm going to type in 3.672, and then to get the standard form on my calculator, I'm going to use the times 10 to the power of x button, which hopefully you can see here. So it's the button that's next to the answer button. You press that, and then your power of -3. So that I've got on my calculator is this part here. I then want to divide it by 1.2, and then I press that button again, times 10 to the power of 4, and hopefully I get the answer that I just got here with my handwritten work, exactly the same as what's on my calculator screen.